हेलो 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 डियर स्टूडेंट्स, हाउ आर यू? हम लोग क्लास 12th फिजिक्स इलेक्ट्रोस्टैटिक पोटेंशियल एंड कैपेसिटेंस चैप्टर के अंतर्गत हम लोग इलेक्ट्रिक पोटेंशियल एनर्जी टॉपिक पे चर्चा करेंगे। तो आज की जो हमारी हेडिंग है इलेक्ट्रिक पोटेंशियल एनर्जी। इलेक्ट्रिक पोटेंशियल एनर्जी। आज की जो हमारी टॉपिक है इलेक्ट्रिक पोटेंशियल एनर्जी। व्हाट इज इलेक्ट्रिक पोटेंशियल एनर्जी? यानी विद्युत विभव ऊर्जा क्या होती है? इट इज द एनर्जी पोजेस्ड बाय ए सिस्टम ऑफ चार्जेस। इट इज द एनर्जी possessed by a system of charges by virtue of their position. By virtue of their position, when two like charges lie, when two like charges lie, charges lie infinite distance apart, infinite distance apart। जब दो समान चार्ज एक दूसरे से अनंत दूरी पे हो, their potential energy is zero. Their potential energy is zero because no work has to be because no work has to be done in moving one charge, to be done in moving one charge at infinite distance from the other, at infinite distance from the other. But when they are brought closer to one another, when they are brought closer to each other, work has to be done against the force of repulsion. Work has to be done against the force of repulsion. as electrostatic force is a as electrostatic force is a conservative force is a conservative force. This work gets stored. This work gets stored as the potential energy of the two charges. As the potential energy of the two charges. Thus, electric potential energy of a system. Thus, electrical potential energy of a system of point charges may be defined as of point charges may be defined as the amount of work done in the amount of work done in assembling the charges, assembling the charges at their location by bringing them in from infinity, by bringing them from in infinity. Now we consider potential energy of a system. Potential energy of a system of 2-point charges, of 2-point charges. Suppose a point charge Q1 is at rest at point P1 in space. Suppose a point charge Q1 is at rest at point P1 in space, in space. It takes no work to bring, it takes no works to bring from infinite, because there is no field, because there is no field yet to work against, yet to work against, that is W1 becomes 0. Electric potential due to charge Q1, electric potential due to charge Q1 at a point P2, at a point P2 at a distance r12, at a distance r12 from P1 will be, from P1 will be V1 equal to 1 upon 4 pi epsilon naught Q1 upon R1. If charge Q2 is moved, if charge Q2 is moved in from infinity, from infinity to point P2 at distance R12, P2 from distance R12, the work required is, the work required is W2 equal potential into charge. Potential into charge. That is V1 into Q2, that is 1 upon 4 pi epsilon naught Q1 upon R12 into Q2, that is W1. As the work done is stored, as the work done is stored as the potential energy of a system, as the potential energy U of the system Q1 plus Q2. So total potential energy U equal W1 plus W2 equal 1 upon 4 pi epsilon naught Q1 Q2 upon R1. Now we shall calculate potential energy of a system of 3-point charges. Potential energy of a system of 3-point charges. We bring in the charge Q3, we bring charge Q3 from infinity to the point P3, to the point P3 work has to be done. Work has to be done against the force exerted by against the force exerted by charge q1 plus q2. Therefore w3 therefore w3 equal potential at point p3 potential at point p3 due to charge q1 and q2 due to charge q1 and q2 into charge q3 into charge q3 or w3 becomes 1 upon 4 pi epsilon naught 1 upon 4 pi epsilon naught q1 plus q2 into q3 that is 1 upon 4 pi epsilon naught हो जाएगा R13 upon R23. It becomes Q1 Q3 upon R13 plus Q2 Q3 upon R23. Hence, electrostatic potential energy of the system. Hence, electrostatic potential energy of the system equal Q1 plus Q2 Q1 plus Q2 plus Q3 is capital U. Total work done to assemble total work done to assemble the three charges. The three charges that is W1 plus W2 plus W3 that is U equal 1 upon 4 pi epsilon naught 4 pi epsilon naught Q1 Q2 upon R12 plus Q1 Q3 upon R13 plus Q2 Q3 upon R23. Now we shall calculate potential energy of a system. Potential energy of a system of n point charges of capital N point charges U equal 1 upon 4 pi epsilon naught summation of all pairs that is Q I Qj upon R Ij that is half 1 upon 4 pi epsilon naught summation of I equal 1 to capital N, where I is not equal to j, and summation of j equal 1 to capital N qi qj upon r I j. As double summation counts every pair twice, as double summation counts every pair twice, to avoid this factor, avoid this factor half has been introduced. Half has been introduced. Electric potential energy is a scalar quantity, special points, special points regarding electric potential energy. Electric potential energy is a scalar quantity. Electric potential energy is a scalar quantity. While finding its value, the value of various charges must be substituted with their proper sign. While finding its value, finding its value of various charges, must be substituted with their proper signs. Potential energy of two like charges. Potential energy of two like charges. The multiplication of Q1 Q2 is greater than 0 is positive, and the electrostatic force is repulsive. As the electrostatic force is repulsive. So a positive amount of work has to be done. So a positive amount of work has to be done against the force to bring brings charges from infinity to a fixed point. The potential, point number 3. The potential energy of the two unlike charges. The potential energy of the two unlike charges, that is q1 multiplication of q1 into q2 is less than 0, is negative, is negative. As electrostatic force is attractive, as electrostatic force is attractive, so a positive amount of work, so a positive amount of work has to be done against this work to take the charges from the given location to infinity. Conversely, a negative amount of work is needed to bring the charges from infinity to the present location, so the potential energy becomes negative. As electrostatic force is a conservative force, so the potential energy of a charge configuration is independent of the manner in which the charges are assembled to present location. The potential energy is a characteristic of the present state of configuration, not on how this state is attained. Now we will study about potential energy in an external field. तो फ्रेंड्स, इस वीडियो लिंक में इतना ही। आप हमारे अगले वीडियो लिंक की प्रतीक्षा करें। जल्दी हम अपना अगला वीडियो लिंक रिलीज करेंगे जो बेस्ड होगा पोटेंशियल एनर्जी इन एन एक्सटर्नल field. Thanks.